Hello, my friends. This is Scott Moore, and you are watching the SMC Journal podcast. This is a show where it's all about performance engineering in IT today. I'm going to be your host, and I really appreciate you joining me for this podcast, where today we're going to be talking about the concept of a digital twin. Now, I've heard about digital twin as far as a term just in the last couple of years, but apparently it's been around for a lot longer than that. I guess I just started paying attention to the marketing lingo around it. So the first question I have, which is if you've never heard about it, you're going to have, what is a digital twin? More importantly, as a performance engineer, why do we care? So as I started doing research on it, I just came up with more questions and answers. So I figured I would interview somebody who knows more about that. Before we get into this, let's talk about the sponsors that make this podcast happen.
This episode is sponsored by Micro Focus and the LoadRunner Solutions family. That includes LoadRunner Professional, Enterprise, Cloud, and Developer. You know, performance matters. Did you know that LoadRunner Solutions have the largest community of practitioners in the world? Join that community at community.microfocus.com, scan the QR code, and check out the LoadRunner family page on performance engineering, as well as their YouTube playlist that we've got links for in the show notes on smcjournal.com as well as YouTube. This episode is sponsored by Total Performance Consulting. They provide the highest quality performance engineering, automation, QA, and development services possible, and they've been doing so since 2006. With hundreds of years of combined experience in performance engineering, they've helped countless companies tackle and solve complex performance challenges. They can help you with your application performance testing, analysis, remediation, infrastructure evaluation, monitoring setup and analysis, performance testing in a CI/CD pipeline, and many other services that will help your company get, keep, and extend your competitive edge. Get more details at totalperform.com. This podcast is sponsored by Bright Payment Solutions. They provide merchant services for a wide variety of credit card companies. They take most major credit cards at the lowest rates and fees possible, and they can help your business generate higher revenue through a variety of payment solutions they have, including their own point-of-sale equipment and custom software. If you take credit cards for your business, you should contact them and see how they can help you. Go to brighteps.com and tell them Scott Moore from the SMC Journal sent you.
Okay, on with the show. Now, let me share this article that I found that was written back in January by William Bain for rtinsights.com. When I see headlines that mention analytics and the term at scale, the performance engineer in me pays attention. So this article says that digital twins enable real-time analytics at scale. It's a little bit misleading in this article because it talks about two different concepts here. One is in-memory computing and one is the digital twin. I think I want to talk about in-memory computing and make that a separate podcast episode for this, but let's focus on digital twin. The first thing this article talks about mentions, the concept of using a digital twin for IoT stuff. So we have 21 plus billion devices now streaming telemetry out there at us, and we've got to solve the problem of scaling that telemetry at the edge. And this is where the digital twin kind of comes into play. It's got the concept here of the modeling, right? When I hear modeling, I sometimes think emulation, I sometimes think virtualization. I think digital twin is actually more than that. Now let's just go back to the article and look at some of the statements in here. It says, the digital twin can help address the challenge that we have for real-time analytics. And it says it's been around for over 20 years, evolving over that time. I don't know why I'd never heard of it before, but it's widely adopted in the field of project lifecycle management, and it provides a means of encapsulating the properties of a device and modeling its behavior. Instead of just using these capabilities in the design process, you can employ a digital twin to process telemetry as well for the analytics. Well, I start reading through this, then it gets into more about in-memory computing, and to me, that just raises more questions. But what is a digital twin? So that's where I contacted my friend Jonathon Wright, who works for Keysight Technologies. I know that Keysight has been talking about the digital twin for quite some time. They purchased Eggplant Software, and this is kind of integrated into their product. And they also made an acquisition of a company that focuses on digital twin technology as well. So I figured Jonathan's the best person to ask. So with that, let's go to our interview that I had with Jonathon, where I'm asking him these questions. Jonathon Wright, welcome back to the SMC Journal podcast, my friend.
It's great to be back. We said we were going to go back on the show, and we probably have some really exciting new announcements to do. We have, and I'm really looking for geeking out with you about all things performance and performance engineering.
Well, it's been 6 months since we talked, and the last time we did, you had just started out your new career with Keysight. And why don't we talk about what's happened since you were last on the show? What's been going on with you?
Yeah, so I literally, I've been traveling 6 weeks now, 5 different countries, catching up with a lot of our good friends from the Performance Advisory Council. Bumped into Henrik in Amsterdam, and then I bumped into Andy at the Swiss Testing Days, and of course our good friend Todd DiCaprio out in Vegas. So it feels like by just random coincidence, the whole pack team is getting back together again. But yeah, so lots of things have happened. A lot of time in R&D, which we kind of thought there was going to be. A lot of thought leadership, and really bringing some of these new capabilities to market. So a lot of excitement around things like the metaverse, which I know is going to sound crazy, as well as digital twins. So I literally flew back from Santa Clara last week, and I was there doing filming for a documentary on digital twins and artificial intelligence with a lady, Dr. Poppy Crum, who's a neuroscientist from Stanford University. So we were kind of getting through into this kind of, well, what is a digital twin? What does that actually mean for, you users? And so that was a really good opportunity to sit there with the people like IDC and the analyst community and try and understand and navigate from the hype to, well, what does that actually mean for us engineers?
That is a great segue into why I wanted you on the show today, because I've been seeing the term digital twins for a while, and I've been wanting. I know that you know about this. You're the person to ask about this. So, from a perspective of my audience is the performance engineers, the performance testers. We're going to want to know, what is a digital twin? Explain it to us, and clear like we're 5 years old, I guess, and then tell us how we would care about that as a performance tester or performance engineer. How does digital twin, how does that technology relate to performance?
Yeah, fantastic question. And I'd done a quote in the last book, the software testing, AI for software testing. And I kind of touched upon the concept of digital twin, which isn't a new term. It's been around, especially in hardware, for at least the last 20 years. And so I described it as a way of understanding a blueprint or a schematic of a physical system digitally. So I guess the first ever digital twin, if we go to Apollo 13 and think of, Tom Hanks, Houston, we have a problem. They went off and created models of the Apollo spaceship. Obviously, they didn't have access to the physical one, and they tried running a whole stack of simulations to try and work out how they could bring the astronauts safely back. So in a way, they already had a digital twin of the Apollo 13 back then. So like I said, not something that's new. It's been around for a long time. But why should we care is the big question. And, I think Keysight have been working with digital twins for a long time. But when they talk about digital twins, they're typically talking about a physical system. So they're talking about a piece of equipment that actually is based on the rules of physics. So, think of an instrument of any particular type or size. So it could be something like a wind turbine. You can create a digital twin of a wind turbine to model very easily, because you understand all the components that are made in it, how the tolerance levels within those components, all the signal inputs and outputs. And so therefore you can run these kind of simulations and emulations. And there's a bit of a definition between the two. And I must admit, this wasn't me. I asked Paul Gerard, and I then asked Dr. Poppy Crum, and she said the difference between a simulation and an emulation is an emulation is based on rules of a physical piece of hardware or something that you built in the past, whereas simulation you can change the boundaries. So if you wanted to say, well, actually it's within this tolerance, you could say, well, what happens if you didn't have that component in it and it had a higher tolerance? What would happen? So you could simulate, airflow on a car or something like that, or how an engine would work. And you could tweak each one of those components. So something like MATLAB, whereas an emulator typically emulates a physical piece of hardware. And that's how we think about digital twins, is a emulator for a physical system. And, we kind of launched, so my first day actually at CES in Vegas this year, we launched a autonomous car radar emulator. And that was exactly what it said on the tin. It's emulating the signals that showcase whether a person's walking across visually, if there's an animal running across the road, all these different inputs. So that way you don't have to use a real, car to actually go through and run your models. Now, autonomous vehicles and self-driving cars and stuff sounds like the future. And, if you're a performance engineer, well, why should we care? Is because software digital twins have just started coming about. And that's really where the explosions happen. Primarily around network digital twins, which again is a very established field, but actually now it's becoming more and more prevalent, especially with the fact that you've got these kind of complex multi-mega cloud configurations and massive complex network topologies with SDNs, and it's actually really difficult to actually model out, okay, well, I'm moving that workload to the cloud. What does that mean? What's that mean for our experience? Suddenly we do care about it, because we all know performance is also down to the underlying network and how that's configured and set up. So suddenly our ears start perking up, and we have something to start thinking about.
So I could see digital twin technology being very useful in the realm of IoT, the devices for when we're going to build smart cities and all those things that report back, telemetry from different like very small devices. But now I'm thinking, okay, this is not just like when we talk about mocking or service virtualization or something. This is sort of like to the next level, right? Because this would be, I don't just care about emulating the network response and controlling how fast something returns a response. This is around the performance of the device itself, the hardware device that you're emulating. Is that right?
Yeah, you're 100% correct. And actually, I have to paraphrase another PAC member here, who was saying that actually things like network function virtualization, off, let's say, a physical switch. He was kind of going on to the fact of saying, well, actually, what's the difference between Model A and Model A? But Model A over here has firmware version 1.2. Model A over here has firmware 1.0, plus the processor that's actually been delivered in version A over here got refreshed, and now it's got a higher CPU on the network switch, and they've now called it version B with a new firmware. How do I know what that difference is going to be, what the impact that's going to be in the performance of my high performing network? And maybe we didn't need to get to that level before, but actually I wanted to kind of give a bit of a backstory, in the sense of, I was just sat there thinking about this the other day, and I was thinking 1993 was the first time someone paid me to do anything. And the first job that I had, I was a fairly young kid at the time, teenager, and I went and installed some 10 base 2 and 10 base 5 network cable in a manufacturing plant. And it was so that they could have a printer, an impact printer, dot matrix printer in the factory floor. And, they could send from accounting or the team in another building the requests for what needed to be manufactured that day. And I remember making my first mistake, which was I laid down 10 base 2 and not 10 base 5. Now, for us who have been long enough to remember Terminators, not the Terminator, 10 was the megabits, and then the 2 was 200 meters or 500 meters, right? And obviously, it was far enough away that it needed 500 meters. But of course, back then, we could understand how it had been configured. You could literally trace the network topology by following the cable and seeing where the end terminator was and whether it was a token ring or some other kind of configuration of how the systems were done. And then, in the 90s, I remember Wilson Marr kind of starting to tell me all this great stuff about performance engineering, which I didn't know anything about. And, I know we've talked about in the past, touching Astra load test and I did a really good retro demo for Joe Colantonio at one of the performance guilds on, doing the same thing as LoadRunner does now with, Astra load test. And, I started that journey and I was always very focused on things like, well, how much memory has the app server got? How's JBoss configured? And, I was lucky enough to spend time with one of the first CPS certified LoadRunner guys from IBM and tried to embrace myself with all this kind of knowledge because I didn't know, how the Java engine was going to be optimized for a particular, Flex application or some Cold Fusion platform. It was complete, crazy science to me. And then, unfortunately, this gentleman called Todd DiCaprio, who and we both know really well, my brother from another mother, turned up and did a presentation when he was working for Shunra on network virtualization. And he kind of blew my mind. And it was the first time I'd ever met him. And I kind of walked up to him after the session. I was like, where did you get these metrics from? They're just, I never thought of any of this. And what had upset me the most about it, which is why I wanted to ask him so badly what it meant, was he was kind of alluding to the fact that actually by adding mobile traffic, just the additional latency overhead of it may be 1.6 seconds instead of 400 millisecond round trip, starts holding up resources at the back end, which means that actually it puts on more load. So going up 5% on actual mobile users would have a decremental effect on the back end systems. And I never really thought about that. And I never thought about, all those sessions that are open, all those resources that are open, all those threads. Yeah, of course, it makes complete sense. But how do I, without a fancy piece of kit like a network virtualization tool, a network virtualization switch, how do I emulate that when I'm doing, my testing? And we both know, LoadRunner, which has always been the flagship in this kind of landscape, bought Shunra and then implemented it into LoadRunner natively, which allowed people to, record like a PCAP recording with your packet loss and your network conditions, and then actually be able to add software network virtualization. I think this was a huge step forwards for us to think about, well, why is it important to understand network? Because every network's different, especially when you think of corporate network, even just you dialing onto a VPN at your office, and then having to be routed to New York or something. Suddenly all this latency starts adding in, and suddenly you think to yourself, why wouldn't we want to be able to test this, right? And now you can pretty much deploy a Raspberry Pi somewhere, benchmark it, and be a load injector, whether it's NeoLoad or something like that, which can then again do the same thing but more realistically. So how do we get better at this? And that was the kind of the question, and why I've got very excited about digital twins and network digital twins, but also how they move on to creating software digital twins as well.
With Keysight and their background in the hardware area and hardware performance, networking device performance, and then the Eggplant acquisition now into software testing of those systems, Keysight has a vested interest in digital twin technology. And I want to bring up an article here on the screen. It's not actually an article, it's a website. It's the Scalable Network Technologies website. And this talks about the network digital twin ecosystem. And Scalable Network Technologies was also acquired by Keysight as well. And I don't know, I'd like for you to talk a little bit about this. How does this relate to Eggplant, the testing? How does it all play together, and how is Keysight leveraging this digital twin technology in their portfolio?
Yeah, so this is a really exciting acquisition we did the back end of last year, and I've had the opportunity and the pleasure to work with the Scalable Network team now. We're working on one of the metaverse projects as well, which I'll go into later on. But if you go to scalable-networks.com and just play any of those 3 videos which are on the screen, you'll be blown away. It genuinely feels like the Terminator 7 trailer. It feels like Skynet has taken over and it's all learning itself. But actually it isn't. It's quite a simple technology, but it's came from the military background, which is where we find, uses of things like the HoloLens 2 technology as well, which again relies on these kind of capabilities. Now, what it does is it actually models out an entire network topology, and it auto discovers that topology, whether it be a hybrid multi-cloud tenanted system, a VPC, which you've privately spun up in AWS, Azure, or some availability zone, whatever it may be. It will build that entire model out, very similar to what you see with tools like Dynatrace and AppD and Splunk. They build this model of the entire network system, but for them it's a level lower. So they're capturing, if we think about, I mentioned PCAP before, which you can get from something like Wireshark or TCP dump if you're just using Linux or whatever. You want to capture that traffic and intercept it. But, and things like Burp Suite has been, people have been using that, and Kali from Linux to be able to capture the network and do these kind of man in the middle stuff from a security perspective. But actually now you can capture that entire network, all the Cisco configurations, the whole stack, and then you can build and overlay a GIS model on top of it, which then allows you really, when we talked about that idea of MATLAB, is creating a 3-dimensional model of that, let's call digitalized battlefield, right? So you can actually see where your antennas are, you can see where your repeaters are, you can see where your line of sight, microwave, communications are going, you can see the signals, the bandwidth, what's being transferred over them, whether or not they've been jammed by an enemy and they're actually now having to revert onto some other kind of backup communication platform. And you can simulate and emulate those kind of configurations. And we do it with nuclear submarines and ships, battleships. We do fighter planes. It's all reliant on this, being able to model this technology out, and for communication to not lose anything in those kind of critical infrastructure and military kind of applications. Again, you might be sitting there thinking, well, we're not the DoD, right? We don't need this kind of tech. But like everything within military, whether it's your radar on your car, which does your auto braking, it's kind of one step past. We've got this capability. Now we can apply it to just your topology, your desired state out. So you might be, terraforming everything in K8, and you may feel that you're in complete control of your new shiny kind of cloud first ecosystem. And then something happens. Cloudflare might not be configured correctly, or there might be some kind of DNS attack or DOS attack. Part of it is whatever that scenario is, and you've got to start looking at systemic failure and what parts of, the things of like chaos testing, chaos engineering of scenarios where, the undesired states happen. We know this happens in the real world. We're all used to this 404, as your t-shirt always has. Why is it so bad out in the real world? And it's because we don't have all these emulator tools, which are, obviously, one thing, but we are not able to simulate those real world conditions with real users. My last call was with I can't say which one, but a popular streaming service company who kind of said to us, we want X amount of our boxes, and we also want to, test them. We want to see, the CDN, do CDN testing, and we want to do video stream analytics around what's the quality of, what's the frame drop, what happens when the hardware's overheating because it's 40 degrees in the UK and no one's ever used to it. What are all the different elements that we want to do, and then how do we simulate and emulate those realistically, because we don't want to just throw them in our network and put those, TV streaming units all on the same network and it suddenly be, fantastic quality. We want you to like Real Media used to do, is kind of say, okay, well, purposely start adding packet loss into here. What happens when you suppress the bandwidth? What happens when you switch from a Wi-Fi 6 signal at 5G down to 2.5G? What happens when you go from 5 to 4 to 3.5 to poor to edge to, LTE? What's the difference in each location? And what does that actually mean the experience is? And we know what the experience is. We spend half our time looking at technology going, why is it still telling me it can't connect? And you're thinking to yourself, it's because, the application's been tested, but, there's some black magic where you've got to be some kind of Cisco black belt with 1,500 qualifications to even, understand how to configure a load balancer. So everyone leaves everything at the standard config. And then people are pulling down containerized versions of Neo4j or Mongo with just the default configuration. And they're going, oh, well, it's fine. We'll use a schema registry and we'll use everything as the default settings. And then we'll change those and tweak them when we get into production. And then they go to your door, knock on the door and go, Scott, can you do some really good performance engineering? And then we're going to do some tuning and, optimize the database caching, do some wizardry, which I don't even know how DBAs actually, do any of their stuff because it's just way too complicated. And then we'll then improve performance through or throughput by 20, 30%. And that's just, of course, there's some great companies out there, Alchemist and a few others that do that kind of container tuning and environment tuning, using machine learning and AI. But, for the rest of us, and the ones that are starting to use this technology and abstract the complexity by using just the default and don't want to change things, what does that mean for them? How can we tell them that actually it's really important to have enough bandwidth between your two availability zones? Because otherwise you're going to have a delay between, your score over here and your score over here. All those kind of decisions are sometimes not informed decisions that they don't really know. If you're using Google Cloud, sometimes it recommends a particular tiering system, but it's magic, and that's why I think we all need digital twins in our life to be able to run those scenarios, and also I don't want to say simplify it, but deal with the extreme levels of complexity and allow us to actually understand it and then be able to model performance scenarios that say to us, okay, what happens if we do this as a scenario? And people would then understand. And like you said, start with one and then start with, well, how many more do you need? How many people are running, those those traffic and ambient noise garbage collection, how much has that been scheduled? How many are they using compute to do, some ML or computer vision crunching in the background? How do you know what's going on in the real world? What requests are coming at the APIs and at what volume, and what's happening with ETLs and all that kind of stuff? It's a minefield of complexity. So I have no idea how we're going to get to a point where we can say, push the button, but I think we are understanding the complexity and we're ready to start utilizing some of this cool tech to help us, guide us in the future.
So I'm going to stop the interview right there. There was so much covered in this conversation with Jonathon, and it's a lot to process, even for myself. So I figured let's break this up. We'll make this a 2-part podcast. Think about what Jonathon said so far, and then he goes into some other things in the areas of VR and machine learning and AI. And so let's talk about that next time. But what do you think about what Jonathon said? I'd like to hear your opinions, and if you have any experience with digital twins, I'd like to hear about it. You can always contact me at my site. That's at scottmoore.consulting, and you can also reach me through LinkedIn and through Twitter through my profiles there. There's the URL for LinkedIn, and Load Tester is my handle for Twitter. I'm also available through email at help@scottmoore.consulting. Would love to hear from you. If you like this kind of podcast, it would be great if you could subscribe to our YouTube channel. We would love to have you. And this kind of lets me know if I'm on the right track or not. You can put comments on the videos, but you can also comment on other social platforms as well. For now, let's end the broadcast there, but we'll be back next time to finish that conversation with Jonathon Wright and talking about digital twins and all the other stuff Jonathon wants to talk about. For this episode, this is Scott Moore for the SMC Journal saying thank you for being with us, and we'll see you next time. Bye-bye.